Miguel, this is your problem 9.5. And what I did is I just copy and pasted what you sent me. And again, because these are algorithmic, I appreciate you doing that because I don't have the details until I see. Because I think you've got a couple of attempts in the homework open, so I didn't know particularly which one you're working on. So thanks for sending. You said you were unclear about the terminology. Let me just kind of walk through this, and then maybe if you got some time over the weekend or Monday on Labor Day, we can touch base and see what we can do to get squared away. But the way that I have set up all of these problems in the homework is similar to this one, and I've tried to do it to make sure that it sort of matches what you're doing here in your homework, so that it has kind of the same look and feel. So this problem has two decision variables, W, the number of servings of wimpy sauce, and then D is the number of servings of dial 911 sauce. So the decision variables W and D are right below the respective letters. And then the values that you see below the decision variables come from the fact that the gentleman sells wimpies for, I believe it's 46 cents a serving, and the 911 is for 59 cents per serving. And then the next thing to discuss here is the value of the objective function. And the objective function in this case is just computed by taking the product of the number of servings of wimpy times 0.46 plus the number of servings of dial 911 times 0.59, and that's the objective function. And that is done using this sum product function in Excel, which takes effectively the product of the decision variables times the product of effectively the objective function coefficients and adds them up. And that's exactly what we want to do. And then just like it's set up here, there are four constraints: the amount of beef, onion, special sauce, and hot sauce that's used to make both sauces. And so what I've done is I have laid in these numbers according to the descriptions of each. You definitely want to go back and make sure I didn't make an error here. And then what happens in this cell is basically I'm going to compute the amount of beef that is used. I shouldn't say that I'm going to, but Excel is going to compute the amount of beef, onion, special sauce, and hot sauce, respectively, that is used as it looks for the optimal solution. And then when we get to the constraining portion of this, we want to make sure that we don't use any more than, I believe it's 21 pounds of beef, 16 cups of onions, 89 ounces of the Kilgore sauce, and 61 ounces of hot sauce. So this computation is just the value of each decision variable times the amount of beef for the wimpy sauce and the amount of beef for the dial 911 sauce. That's going to be computed in this cell, and then so on and so forth down the line. Notice that because I just took this formula and I pulled it down, notice that I put the objective value or the decision variables in, I put dollar signs in front of them so that when I pull this cell down, these values don't change. However, the coefficients do change. So you can see B5 C5 times B10 C10, and then B5 C5, B11 C11, so on and so forth. So at this point, we're ready now to go to the solver. I think I might have already had this set up. So the objective function is in cell C7. So I want solver to actually, this should be, in this case, I think we want to maximize this. So let me get out of that. Let me close that. I'll go back to that in a second. That is the cell that I ultimately want to. We'll cancel that, but I just want to change this so I don't confuse you here because we want to maximize profit. And so let's see, I think, yes, maximize the profit. So let me just go back to the solver setup here. So we want to maximize cell C7. Notice I've got maximize chosen. And then the decision variables are in B5 and C5. And then I really I can put the constraints in just one constraint in solver. So what we want is we want D10, 11, 12, and 13 to be less than or equal to F 10, 11, 12, and 13. And that is in the constraint window here. So we're ready to solve. Because you want sensitivity data here, make sure you're using the Simplex LP because that's the only solver type that will give you the sensitivity data that you want. And so when I hit solve here, what do we get? It looks like, let's see, we're going to make, based on the scenario here and the amount of product that you have, it looks like we're going to make 10 servings of the Wimpeys and 10 servings of the Dial 911. And the profit will be $10.48. And here's the outcome on the constraints. Now, because you want sensitivity data, as soon as you solve the model, just click on sensitivity and hit OK, and you're going to get another report. I think it's this 9.2. Yes. So in this file, I'm going to send you this file, ask you to take a look at it and see if this setup helps and the video helps to perhaps maybe add a little more clarity to some of these concepts. And then you can hit me back and I can do that other one or help you set up that other one as well. Sensitivity report, let's see. So remember, the optimal solution is the value of the decision variables after the model is solved. So I believe, assuming all my values are here are correct, and you're going to want to check that, 10 servings of Wimpeys, 10 servings of Dial 911, the profit, $10.48. Now, before you start answering these questions, it's always good to take a look at the constraints and see what happens here. So it looks like the limitations were on the special sauce because we used all the special sauce and we used all the hot sauce. So we're going to want to keep that in mind as we go look at the sensitivity data. It says, what is the shadow price of the special sauce? So if you look at your sensitivity report, the special sauce looks like it's got a shadow price. Let me see, what did they ask for? A number of, let's see, round your answer to 2 decimal places. So let's see, 0.076. So if we're rounding that to 2 decimal points, it looks like the value of the shadow price is 8 cents, and I think that's computed in ounces. So the shadow price in your case is going to be 8 cents. Interpret the shadow price. Remember, because the special sauce, we used all of it. Effectively, what that says is for each, let me see, make sure that's ounces. Yes, ounces. So for each ounce of special sauce we were able to add to the right-hand side, we would add about 7, let's see, what did we say again? About 8 cents. We would add 8 cents to the profit. Now, there wouldn't be any change in the values of the gosh almighty, the decision variables. Sorry about that. But there would be a change to the value of the objective function. And there are some allowable increase and decrease. Remember, what this means is the change in the value of the objective function for each ounce that you add or subtract has to be within these bounds to apply this shadow price. And it looks like there's a fair amount of tolerance on that. So in this case, if you have 1 more ounce of special sauce, you would increase the profit by about 8 cents. Then it says increase the amount of special sauce by 1 and resolve the model. And let's see if this makes sense. So if we've done this all correctly and we interpret this correctly, if I increase the amount of special sauce by 1 more ounce, 90, what I should expect to see when I solve the model is this should be around $10.56 is what we're hoping. So let me just do that. I'll zero these out so we're not, so we're starting from scratch. So let's go back here. Let's go to the solver. We don't need to change anything. We just need to solve it again. And just like the sensitivity data suggested, the new value of the objective function is $10.56. And remember, that's just 8 cents more than what we had before, and that's because you added 1 more ounce of special sauce. And again, just one more time, that 8 cents comes from the value of the shadow price when you round that to just 2 decimal places. So let me know if this helps, and I can set up that other one or help you set up that other one, and then you can go from there. And if we need to catch up by phone, we can do that. Thanks.